Okay, this video is about geometric sequences, how they work, and how to find the general term or the nth term. Right. So here's some geometric sequences. Just have a look, see if you can spot what's happening. You see here on the left, 3 times 2 is 6 times 2 is 12 times 2 is 24 times 2 was multiplying by 2. Same with the one below. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. On the right here, we're dividing by 2. 24 divided by 2 is 12, divided by 2 is 6, divided by 2 is 3. Actually, it's better to think of it as multiplying by half. And here we're dividing by 5 or multiplying by 1/5. And I'm going to show you that in a second. So the thing with geometric sequences, we're always multiplying by the same number. And that number, we're going to call the common ratio R. So each of these terms, and we use U for terms, so term 1, term 2, term 3, or first term, second term, third term. How to get from one term to the next term is multiplying by the common ratio. So in this first example, the common ratio is 2. This one on the right, common ratio is 0.5. Here, again, it's 2. Here, again, it's 1/5 or 0.2. If you're not sure how to do that, just remember that the common ratio is the second term divided by the first term, or the third term divided by the second term, or the fourth term divided by the third term, right? It's the common ratio, the ratio between two consecutive terms. Once you have that, you can get an equation, or you can see the relationship between each of the terms. So U2 is U1 times R. And U3 is U2 times R, or U1 times R squared. So every time we're just multiplying by R. So this is the general form of this sequence. So you can say for one term, it will be the first term times R to the power n minus 1. So the first term, 1 minus 1 is 0, R to the 0 is 1, it's just U1. The second term is U1 R to the 1. Third term is U1 R to the 2. Fourth term, U1 R to the 3. So this is the formula for general term. So let's quickly see how to apply that. So for these two, the general term here will be U1 is 3, R is 2. So we put it in this formula over here. So it's going to be 3 times 2 to the n minus 1. That's all you can do in that case. In this case, we got 24, and we're multiplying each time by a half. So we're going to put that in the equation like this, U1 R to the n minus 1. And depending on the question, this is probably the final answer. I'm going to show you something a bit later. Okay, let's have a look at another couple of examples though. This one, 2, 4, 8, 16, 32. U1 is 2, R is 2. So we're going to put this in the equation 2 times 2 to the n minus 1. Now, that's the final answer, that's cool. But actually, if you look at that, that's not really the final answer, because we can easily simplify that, right? This is 2 to the 1. So 1 plus n minus 1 is just n. So this simplifies to 2 to the power n. Same over here. U1 is 25 and R is 1/5, 0.2, 1/5. So if we put that in an equation, we get this, which is great, which is all correct. But actually, when I see this is 5 to the power 2, and this 1/5 is 5 to the power -1. So I'm going to write that as powers of 5. And when I expand out these brackets here, I'll get -n plus 1, right? -n plus 1. So the answer, so -n plus 1 is 1 minus n. So now, and when I add those two together, I'll get 5 to the 3 minus n. Okay, so have a look at that carefully. Make sure you see where each step comes from. But when you see things here in your initial answer here, when you see that there's fives inside, this is a multiple of 5 and this is a power of 5, try and simplify it a little bit. Okay, we'll go back to the one we did before. This one, right? What I know about 24 is that it's 3 times 8. What I know about 8 is that it's 2 to the power 3, and a half is 2 to the power negative 1. And then I can go, okay, we've got the 3 at the front, but these are all powers of 2, so I can simplify that. So negative 1 times n minus 1 will be 1 minus n. So then you add on the 3, so it's going to be 2 to the 4 minus n. So the final answer is 3 times 2 to the 4 minus n. Depending if this is the final question or part of a bigger question, maybe this will be more useful, or maybe this is more useful, right? So you've got to be able to see how to convert between both. All right, I'm going to show you some graphs now. Go back and look over any of these examples if you need to, and write a comment if it's not clear. But let's look at some graphs. I just wanted to illustrate the idea of geometric sequences using this little spreadsheet with a little graph here. So you can see if we have U1 is 3 and R is 2. So every time I'm multiplying by 2. If you look, as you go up in the number of terms, the size of the term just gets bigger and bigger. So it's kind of this exponential J curve going on. But if you have, instead of a R of bigger than 1, if you have a R less than 1, what will happen is the number will just get smaller and smaller and smaller. So you can see here, you multiply by a half every time. So it's 3, 1.5, 0.75, 0.375, etc. So it just gets smaller and smaller and smaller and closer to 0. So that's the big difference between the positive and the negative, right? You've got a positive R, no, not positive and negative. R bigger than 1 and R less than 1. So if R is bigger than 1, like here, it's just going to get bigger and bigger and bigger. The terms are just going to get bigger and bigger. But if R is less than 1, the terms are going to get smaller and smaller and smaller. The other thing is what I just accidentally mentioned is negative. So if you got a negative number that's less than negative 1 or bigger in magnitude than negative 1, it's like here negative 2, the numbers, this absolute value of the number is going to get bigger and bigger, but it's going to go positive, negative, positive, negative, positive, negative. So you can imagine on a graph like this, positive, then negative, positive, negative, positive, negative, positive, negative, positive, like that. Because when you multiply negative times negative, you get positive. And negative times positive is negative. That's why it keeps switching here. And same if you've got a number less in magnitude than negative 1. So between negative 1 and 0, what's going to happen is it's going to get smaller and smaller and smaller in size, but closer and closer to 0, but it'll go up and then like below and then above. So below, above, below, above, below, and above. Negative, positive, negative, positive, negative, positive. So it's good to keep that in the back of your mind when you think about these sequences, because you can kind of picture what's going on and picture how to apply it. All right. Hope that makes sense and is helpful. Questions below. Give me your comments. Thanks a lot. Bye.